Hey folks, welcome to the NCEA Level 3 Calculus differentiation paper from 2024. If you're joining us for the first time, the way this video works is I go through each question and let you know what you need to do for achieved merit and excellence. The best way to watch this video is to pause the video at the start of each question and then try the question out by yourself and then unpause the video just to see how I go about doing the answers. So without further ado, let's get started. So question 1a, what we've got is we've got just a differentiate, straightforward one. Don't need to simplify the answer. So before I even start, what I'm going to do is I'm going to write this as f of x 4 minus 9x to the power of 4 to the power of half, because it just makes it easier for me to kind of manipulate things from there. So then I'm going to do f dash of x, which is bring the power in front, which is half, multiplied by 4 minus 9x. To the power of half minus 1, that's going to become negative half. And then I have to multiply it by the differentiation of this. And I just realized I forgot the 4 there. So multiplying by the differentiation of the bracket, which happens to be just, well, the 4 disappears. Minus 9x4 differentiates to negative 36x cubed. Now you can actually leave your answer like this because it does say that you do not need to simplify your answer. So I'm going to leave it here. And the grade for this question is an achieved. Going to question 1b. So what we've got is we've got a curve that's defined by this equation. Find the gradient of the tangent to the curve when x equals to 0. So we're looking for f dash of 0. So we need to figure out what the f dash of x is. Now the problem is we've got to kind of have a look at this. This is actually going to be a product rule because there is two functions that's actually getting multiplied here. So I'm going to write this as u and v. So if that's the case, then I can say that f dash of x equals u dash v plus u v dash. Now, you know, you could do it this way. You might have do it completely different way. As long as you use the product rule, then you're pretty much good to go. So u is equal to x squared plus 3x plus 2. And therefore u dash is equal to 2x plus 3. V is equal to sine x. And then v dash is equal to cos x. So we're going to get f dash of x is equal to u dash, which happens to be 2x plus 3 times sine 0, plus u, which happens to be x squared plus 3x plus 2, multiplied by v dash, which happens to be cos x there. That should have been a sine x. A lot of silly mistakes this morning. All right, so that's f dash of x. Once we got f dash of x, now we need to substitute 0 wherever x is, and we're going to try and figure it out. So the first bracket is going to be 3. Sine of 0 is 0, so that's going to become 0. Then on this side, we've got just 2 multiplied by cos of 0, which happens to be 1. So we should get a gradient of 2. So grades-wise, you need the correct gradient of the tangent with correct derivative to get an achieved. So you need the actual answer, plus you need this line here. All right, so for the next question here, what we've got is we've got a function and we need to figure out for when this function is decreasing. So for function is decreasing, we are looking for when is the gradient less than 0. So we're going to work that out. So we've got f of x is equal to 3 times 2x minus 7 squared plus 60 ln of x plus 12. So when I do f dash of x, here I've got chain rules, so I'm going to do 3 multiplied by 2, 2x minus 7 to the power of 1. Then I've got to multiply by the differentiation of the brackets, which happens to be 2, plus 60 ln x. When I differentiate that, I'm going to get 60 times 1 over x, and the 12 actually disappears. So what I'm ending up with is f dash of x equals, what I got, 6 times 2. Now I've got 12, no, hang on. I've got 12 times 2x minus 7 plus 60 over x. Then f dash of x is equal to 24x minus 84 plus 60 over x. So basically what I'm trying to figure out is when is this particular graph less than 0. So I got 24x minus 84 plus 60 over x, and I want to figure out when is this going to be less than 0. And that's for decreasing functions. So the first thing I'm going to do is I'm going to multiply everything by x, because I don't like that x in the denominator. And when I do that, I'm going to end up with 24x squared minus 84x plus 60 is less than 0. So I now need to kind of figure out what's happening with this graph. Now, there's multiple ways I've done this before for this type of question. What we can do is we can actually simplify it, and then work out the roots. But because we've got the graphics calculator here, I'm going to go straight into this. So what I'm going to do is I'm going to click on, where am I going to go? Equation. So let's head down to equation. And I'm going to do F2 degrees, and I've got 24 minus 84 and 60. Now, as you can see, I'm actually getting two values here, which is 1 and 2.5. So remember this, and I think I did this, in the last level 2 and level 1 as well. So what you do is, if you look at this particular value here, this is 24x squared. So this is going to be a positive parabola. The next thing what we're going to do is we are going to actually find what the two roots are. And in this case, we've got it from the calculator, which happens to be 1 and 2.5. And of course, we're looking for when is this graph less than 0. So for less than 0, we're actually looking at this particular zone here. So we can actually say f dash of x is less than 0 when x is between, well, actually no, I probably should write it like this, when x is between 1 to 2.5. That's pretty much it for this question. So grades wise, part 1 is achieved. So this is achieved here. And finding the correct inequality, and I think the inequality, the right one, is going to get you a merit. Now, if you just put down 1 and 2.5, then I think you're only going to get achieved for this question. All right, question D. So question D, what we've asked is find the x values of stationary points on the graph and determine their nature. So we've got f of x equals 2x minus 1 multiplied by e to the power of negative 2x. Now, straight away I can see that when something is getting multiplied with another function, I am looking at a product rule. So with that in mind, what I'm going to do is I'm actually going to work that out. So I've got u and v. So u is equal to 2x minus 1, u dash is equal to 2, v is equal to e to the power of negative 2x, v dash equals negative 2 e to the power of negative 2x. Yeah, so that's it there. Now I'm going to do f dash of x. So f dash of x is equal to u dash v plus uv dash. So u dash is equal to 2e negative 2x plus u, which happens to be 2x minus 1. V dash is going to be negative 2 e to the power of negative 2x. All right, so the next step is just trying to see what else I can do here. So the first thing is I need to figure out what the stationary points are. So I'm going to actually kind of see if I can simplify this a little bit better. What do I got? E to the power of negative 2x is a common factor. So I'm going to take that out completely, which means I should be left over with 2 plus 2x minus 1 multiplied by negative 2. That looks all right there. So then I've got e to the power of negative 2x brackets 2 minus 4x plus 2. And that's going to give me e to the power of negative 2x times 4 minus 4x. So this is what f dash of x is. So I now need to put this equal to 0 to try and figure out what, what the turning points are going to be. So doing that here, I'm going to put e to the power of negative 2x multiplied by 4 minus 4x is equal to 0. Now e to the power of negative 2x, that's not going to actually work out. That's not going to equal to 0. So we're going to ignore that. And so the only thing that we can look at is 4 minus 4x is equal to 0, which in this case tells me that x is equal to 1. So I've got x is equal to 1, which is a stationary point. Now I need to figure out whether this is going to be a max or a min. So to do that, I need to find f double dash of x, and then I'm going to substitute 1 in there to try and figure out what's happening in that point. So for f double dash of x, I've got f dash of x is equal to e to the power of negative 2x multiplied by 4 minus 4x. Now, I've got to do this whole formula thing again because I've got f and g, and I've got to use product rule again. So if f is equal to e to the power of negative 2x, f dash is negative 2 e to the power of negative 2x, and if g is equal to 4 minus 4x, g dash is equal to negative 4. So with that in mind, I now have to combine f double dash of x. So f double dash of x is going to be f dash g plus fg dash. So I'm going to get negative 2 e to the power of negative 2x multiplied by 4 minus 4x plus e to the power of negative 2x multiplied by negative 4. So now what I've got to do is I've actually got to substitute 1 in there to try and figure out what this value is. Because f double dash of 1 is going to tell me whether this point is a max or a min. So I've got negative 2 e to the power of negative 2 times 1 is just negative 2 multiplied by 4 minus 4. So that's going to become 0. Then all I'm left over with is negative e to the power of negative 2 times negative 4. So I'm just going to put that in the calculator, and I think this number is going to be a negative number, but let's try it out anyway. I've got negative 4 multiplied by e to the power of, where is e? E to the power of negative 2, and that's going to give me negative 0.541. So basically, since f double dash of 1 is less than 0, x equals to 1 is a maximum point. So grades-wise, correct expression for dy dx gets you an achieved, and I guess you don't have to simplify it, so I'd probably say there. And then find x equals to 1 and justifies is going to get you that merit grade. All right, and we go to question 1e. So 1e, what happens is that we've got this equation here, blah, blah, blah. Curve has a point of inflection at the point P. So if it has a point of inflection, we know that f double dash of x is equal to 0. And then they're saying find the equation of the tangent to the curve at point P. So basically we double differentiate this function, and then we put it equal to 0 to find out what the x value of P is. Then we go back to f dash of x, and we find the gradient. We find f of x to find the y value, and then we get the equation. So it's a fairly straightforward excellence question, but let's see how this goes. All right, so first thing is I need to do f of x. I'm going to write f of x as 2x squared 1 over x. I'm just trying to see, is it better to do this with I think it might be better to do this separating everything here, because otherwise it's going to, if I try to use quotient rule for this, it's going to get ugly. So I'm going to write it like this: 2x squared over x minus 1 over x minus 2x ln of x over x. So now I can get rid of this x's here, get rid of that as 1. So what I've got here is f of x is equal to 2x minus 1 over x minus 2 ln of x. Okay, so let's actually do f dash of x first. So when I do f dash of x, I'm actually going to do it here. So if I do f dash of x, 2 differentiates to just 2. Minus 1 over x, when I differentiate it, that's going to become, well, actually, let's actually do this extra step here so you can see why I do this. I'm going to bring x to the numerator, which is x to the power of negative 1 minus 2 ln of x. All right. So now when we differentiate x to the power of negative 1, we're going to get negative 1 comes in the front, x to the power of negative 2 minus 2 times 1 over x. So basically f dash of x is equal to 2 plus 1 over x squared minus 2 over x. All right, so that's f dash of x. Now I need to work out f double dash of x. Now f double dash of x, what I'm going to do is f dash of x. I'm going to rewrite it so that it's easy for me to, I'm going to put the x in the numerator and this one in the numerator as well, just so that it makes it easy for me to differentiate. So if I do f double dash of x, 2 is going to disappear. Then I'm going to get negative 2x to the power of negative 3 plus 2x to the power of negative 2. So this f double dash of x, now this needs to equal to 0 for point of inflection. So I'm going to go f double dash of x equals to 0 for point of inflection. I'm just going to write that down. It's always a good idea to write it down rather than just randomly putting things in. So I'm going to get negative 2x negative 3 plus 2x negative 2 equals to 0. So cross multiplying this, I'm going to end up with 2x cubed equals, 2x negative 3 equals 2x negative 2. And I should actually give it a little bit more room. So I'm going to get 2 over x cubed equals 2 over x squared. So at this point, I'm going to cross multiply this, and I'm going to get 2x squared equals 2x cubed, and then 0 is equal to 2x cubed minus 2x squared. Now, really important that you do it this way, because if you do it the other way where you cancel the x cubed over x squared, you end up with only one value. And I think in this question, you're going to end up with possibly, because of that x squared, just be careful with that. So next is we've got 2x squared as a common factor. So we should get x minus 1. Now 2x squared is equal to 0, or x minus 1 is equal to 0. X equals to 0, we can kind of ignore it because there's a, you can actually see the original part of the question. It says where x is greater than 0. So because of that, you know how you got 2x squared is equal to 0, x minus 1 equals to 0. We're only going to go with x equals to 1. Because x equals to 0 is not actually possible. Because as you can see, I've highlighted in the top of the question where x has to be greater than 0. Okay, so we've got x equals to 1. So now we need to figure out the y value. So we're going to go f of 1 is equal to, I'm going to go back to the original equation, which is 2x minus 1 over x minus 2 ln of x. So f of 1 is going to be 2 minus 1 over 1 minus 2 ln of 1. And I'm going to get this as f of 1 is equal to 1. So the point is 1, 1. Now I need the gradient, which is f dash of 1. Now f dash of x is equal to 2 plus 1 over x squared minus 2 over x. So I'm going to get 2 plus 1 over 1 minus 2 over 1. And that's going to give me, what is it going to give me? 1 minus 1 is, no, 2 minus 2 is 0. And then I'm just going to get a gradient of 1 as well. So my point is 1, 1. And the gradient is 1. So I'm going to get y minus y1 equals m times x minus x1. I'm going to get y minus 1 equals 1 times x minus 1. So I've got y minus 1 equals x minus 1. And then y is equal to x minus 1 plus 1, which is going to give me just y equals to x. Now, I'm going to be brutally honest here, folks. Like, there's a lot of differentiation questions that I've done over the years, and that's probably one of the most straightforward excellence question that you could possibly get. Yeah, it's like nothing too major about it. Grades wise, correct expression for dy dx is going to get you an achieved, so that is right here. A merit, find x equals to 1 with correct dy dx, and okay, so a merit is up to here. E8 is obviously fully correct. E7 is, you could potentially make correct consistent equation. Yeah, so let's say you make a mistake somewhere there, minor mistake, you could still end up with an E7. And that's basically question 1, folks. All right, so question 2, what we've got is find an expression for dy dx, and we're working with parametrics. So if x is equal to 3t squared plus 1, then dx dt is equal to 6t. And if y is equal to cos t, then dy dt is equal to negative sine t. So from this, we can say that dy dx is equal to dy dt multiplied by dt over dx. So we're going to get negative sine t multiplied by 1 over 6t. And pretty much we can leave it like that. That's going to be your achieved grade for this question. All right, next question. What we've got is object is traveling in a straight line. Find the velocity of this object when t equals to 1. So s of t is equal to ln of 3t squared plus 5t plus 2. Now, when I differentiate it, I get the velocity function. So, and when I differentiate an ln, I'm going to get 1 over whatever's inside the bracket, which is 3t squared plus 5t plus 2. But I also have to multiply by the differentiation of this bracket, which happens to be 6t plus 5. And now I'm trying to figure out what's the velocity after 1 second. So I'm going to get 6 times 1 plus 5 divided by 3 times 1 squared plus 5 times 1 plus 2. So I'm going to get 11 over 10, which is also roughly 1.1 meters per second. So grades wise, you need correct derivative, which is this, and you need the correct value, which is this, to get an achieved for this question. All right, so question C, what we've got is show that y equals sine of x squared minus cos x is a solution to this equation. All right, so I guess the first thing we want to be doing is, it's pretty much a proof question here. So we've got to try and work out the right hand, well, whichever, I think it's the left hand side. We try and work out the left hand side first. So we've got sine x squared minus cos x. There's no way to do this without, it's an annoying product rule question, but you know what, that's fine. So we've got f of x equals sine of x squared minus cos x. So when we differentiate it, we're going to get f dash of x. Sine changes to cos x squared multiplied by the differentiation of the bracket, which happens to be 2x, and then minus cos x changes to plus sine x. Now this is f dash of x. Now we need to work out f double dash of x, which is the same as d2y over dx2. So to do that, unfortunately, I have to use the product rule here, because this is your first, this is where the product rule is happening. So I'm going to put this as f and g. So f is going to be cos x squared. Then f dash is going to be negative sine x squared times 2x. G is going to be 2x. G dash is going to equal 2. So with that in mind, I've got f double dash of x. Maybe I should actually go dy dx. Yeah, let's do that. So this is going to be dy dx. So I'm going to differentiate it a second time. So I should get f dash g plus g dash plus f g dash, and then plus the last bit, which is the differentiation of sine x. So how am I going to do this? Now let's actually do it like this. I'm going to write f dash g at the top here so I know what to do. So I've got f dash first, which is going to be negative 2x sine of x squared times g, which happens to be 2x. Then I've got plus fg dash. So that's going to be 2 cos of x squared. Then I've got differentiation of that sine x, which is cos x. So this thing still needs to be differentiated. And I think I've got something here, 2 cos squared minus 4x. Yep, that's all looking good. So this is basically the second part of it, right? Now somehow I need to prove that that is equal to the left-hand side. to the right hand side. So if I was to do that, I've got d squared y over dx squared plus 4x squared y. And up here, this is all equal to 2 cos x squared plus 1 minus 4x squared cos x. So that's what I'm trying to prove. And I think I've just ran out of room here, so sorry, just give me a second. So this is the proof. Now d squared y dx squared, I've already got it, which is negative 4x sine x squared. The reason I got 4x squared is from that, negative 2x times 2x. Then I've got plus 2 cos x squared plus cos x. And then I've got plus 4x squared y. Now y is equal to, I'm going to get y from here, which is sine x squared minus cos x. So now I'm going to expand the bracket just to see what I can get rid of. So I've got negative 4x sine of x squared plus 2 cos x squared plus cos x plus 4x squared sine of x squared minus 4x squared cos of x. So this last part here, I've just expanded this to get that, and that is to get that. Now, I can see that negative 4 sine x squared and positive 4 sine x squared, they're going to disappear. And all I'm left with is 2 cos x squared plus cos x minus 4x squared cos x. And if you look at the right hand side, you've got plus cos x is a common factor, which means I'm going to get 1 minus 4x squared cos x. And this is equal to the right hand side. So grades wise, we are looking at achieved for dy dx, which is here. And incredibly, you've got to do the full proof to get a merit grade for this question. So it's not too bad. It's not too bad. All right, next question. We've got this function here, blah, blah, blah. Find the coordinates of point of inflection on the graph of this function. Okay. You can assume that your point found is actually a point of inflection. So it doesn't, we don't need to actually show it by the looks of it. You assume that. You must assume, okay, no, we do need to. Okay, fine, that's fine, that's fine. Okay, let's do f of x first. So we got ln of x over x. So we're going to end up with g, I think it's going to be f dash g, or u over v. Let's go uv. So u is equal to ln of x, v is equal to x, u dash is equal to 1 over x, v dash is equal to 1. So if we want to find f dash of x, because we have to use the quotient rule for this, we're going to get u dash v minus uv dash over v squared, which means u dash is equal to 1 over x times x minus ln of x times 1 divided by x squared. So we're going to get 1 minus ln of x over x squared. Now that is f dash of x. Now we need to actually double differentiate this. So to do that, once again, we need to do, let's go with a different letter here. So e is going to be 1 minus ln of x. E dash is equal to negative 1 over x. And then f is equal to x squared. And then f dash is equal to 2x. Because we need to do yet another quotient rule. So we got f double dash of x equals, we're going to get e dash f minus e f dash over f squared, sorry. So e dash is negative 1 over x times x squared minus 1 minus ln of x times 2x. And all of that is divided by x to the power of 4. We're going to simplify this a little bit because we're going to get x minus 2x times 1 minus ln of x over x to the power of 4. I can see that x is a common factor, so I'm going to take it out. And I'm going to get 1 minus 2, 1 minus ln of x over x to the power of 4, which then gives me 1 minus 2, 1 minus ln of x, and the whole thing divided by x cubed. So this is f double dash of x. Now I know that for point of inflection, f double dash of x is equal to 0. So f double dash of x is equal to 0. So I'm going to put 0 is equal to 1 minus 2, 1 minus ln of x over x cubed. Now the x cubed disappears, and left with 0 is equal to 1 minus 2, 1 minus ln of x. Rearranging this, I'm going to get 2 times 1 minus ln of x is equal to 1. 1 minus ln of x is equal to 1 over 2. Ln of x is equal to 1 over 2 plus 1. Ln of x is equal to 3 over 2. And then x is equal to e to the power of 3 over 2. Now it's actually asking for the coordinates of this particular point. We've figured out what the x value is, so we need to figure out what the y value is. So I'm going to go e to the power of 3 over 2 equals ln of e to the power of 3 over 2 divided by 3 over 2. It's really interesting. See, I would have got this as y value as that. Sorry, as I was working through, I was looking at the answer schedule, and I think the answer schedule, the answer is actually wrong. The reason is because they've got x equals to, ln of x equals 3 over 2, so x is equal to e to the power of 1.5, but then somehow they've managed to put a negative there. That should actually be a positive value because we've got ln of x, ln of positive x. So I'm not sure how they ended up with that negative 1.5 because the answer I'm getting is 3 over 2 over 3 over 2, which equals to 1. So the point of inflection is actually e to the power of 3 over 2 and 1. Let me just check that in the calculator just to see if I maybe did some mistake. So if I do ln of e to the power of 1.5, yeah, I get 1.5, and then divided by 1.5 should give me 1. Oh, not minus. Sorry, it should be divided by. Yeah, it's 1. Yeah, I think the answer schedule is incorrect there. So achieved for dy dx is going to get you an achieved. So we're looking at an achieved there, and then right here at the end for merit. All right, folks, so for question E here, what we've got is we've got a function, and then it says that we've got a single turning point at Q. Find the x-coordinate of the point. So obviously, we've got to differentiate and put it equal to 0. So I've got f of x is equal to x e3x over 2x plus k. That's a nasty looking equation. Trying to think, product rule. Well, we've got a product rule and a quotient rule together. That's never fun. Because what we have got here is we've got x e3x, so that's product rule. And then we've got the remaining part of it, which is actually a quotient rule. So I'm going to do the numerator first. So, because, yeah, I think this is just one of those questions, isn't it? So let's go u and v. I'm going to go first. U is equal to x e3x. V is equal to 2x plus k. Now v dash, that's simple because when you differentiate 2x plus k, you get just 2. But when you differentiate u, because it's x e3x, you've got to do product rule there. So I'm going to go x e3x. So I'm going to put down f and g for, I don't know, what other letters can I go? M and n. So m is equal to x, n equals e to the power of 3x, m dash is equal to 1, n dash is equal to 3e3x. So u dash would then be m dash n plus m n dash. So m dash is 1, n is e to the power of 3x, plus m, which is x, n dash is 3e3x. So u dash is then equal to e to the power of 3x plus 3x e to the power of 3x. I hope I'm right, because it's like, this is one of those ugly looking equations. All right, so then f dash of x. So when we do f dash of x, we're going to do u dash v minus uv dash divided by v squared. So u dash is e to the power of 3x plus 3x e to the power of 3x multiplied by v, which is 2x plus k, minus u, which is x e 3x, multiplied by v dash, which happens to be 2, all of that divided by 2x plus k squared. So I now need to somehow kind of make sense of this numerator and try and put it equal to 0. Well, actually, it doesn't matter, because I could just go, this whole numerator could equal to 0. So I'm going to say for turning points, f dash of x is equal to 0. And because I'm going to put the whole thing as 0, the only part that I really need to worry about is the numerator. So I'm going to put 0 is equal to e to the power of 3x plus 3x e to the power of 3x multiplied by 2x plus k minus 2x e to the power of 3x. Now from this point, what I can see is I could see that e to the power of 3x is a common factor. So I'm going to take that out. E to the power of 3x is a common factor here. And I'm going to get 1 plus 3x multiplied by 2x plus k minus 2x e to the power of 3x. All right, so the next thing I'm going to do is I'm going to take out e to the power of 3x as a common factor for the whole thing here, which means I should have 1 plus 3x multiplied by 2x plus k minus 2x. Once I have that, I should be able to expand the brackets inside. And what I should get is, I've got 2x plus k plus 6x squared plus 3xk minus 2x. So ultimately, I'm going to end up with e to the power of 3x. And inside the brackets, I'm going to have 6x squared plus 3xk plus k. Okay, so now basically at this point, I've got both of these two brackets and they're equal to 0. So I should get e to the power of 3x is equal to 0, or 6x squared plus 3xk plus k is equal to 0. Now, the thing is, with e to the power of 3x, well, we can kind of ignore that because that one doesn't actually work. So the only thing that we can have a look at is the 6x squared plus 3xk plus k. But the question does say that it has to have a single turning point. So for us, we really want to have x to be one single value there. All right. So in other words, we want to actually show that this part could only have one solution. If it only has one solution, and I hope you can kind of see this, this is where we go b squared minus 4ac is equal to 0 for actually one turning point. So with that in mind, we've got 3k squared minus 4 times a, which is 6, times c, which is k, equals to 0. So what we're going to end up with is 9k squared minus 24k equals to 0. So at this point, we can actually factorize this. So this is going to be 3k. So we're going to get 3k minus 8 is equal to 0. Now with this in mind, what we're going to get is we've got 3k is equal to 0. So k is equal to 0. Or we've got 3k minus 8 is equal to 0. So 3k is equal to 8. And k is equal to 8 over 3. Now, we've basically got two situations here. We've got k is equal to 0, or k is equal to 8 over 3. And what we need to do is we need to substitute both of them into this yellow highlighted equation to see which one is going to give us a single turning point. But if we actually go back to the question actually says something very important, and I kind of missed that. It says that K is a non-zero constant. And because K is a non-zero constant, we can actually ignore K is equal to 0. And we're going to look at just K equals to 8 over 3. So I'm going to put down 6x squared plus 3x times 8 over 3 plus 8 over 3 is equal to 0. So in other words, I'm going to get 6x squared plus 8x plus 8 over 3 is equal to 0. And then I'm going to multiply, what can I do here? I can actually multiply everything by 3 if I want to. When I do that, I am going to get, let's go multiply by 3 here as well. I'm going to get 18x squared plus 24x plus 8 is equal to 0. I'm just going to simplify this. 9x squared plus 12x plus 4 is equal to 0. And at this point, I'm going to put this in the calculator to figure out what I actually get. Where is it? I'm going to go polynomial, and I've got 9, 12, and 4. Now you could have done it with the top line with 18, 24, and 8 as well. And as you can see, I'm getting 2 answers for x. That just shows me that the discriminant is equal to 0. So then here I could say that x is equal to negative 2 over 3. And I believe I found the x value as asked in the question there. So grades wise, correct dy dx. That is a brutal dy dx for an achieved grade. So we're looking at achieved here. For merit, find the correct value of k. So correct value of k is up to here to get you that merit. Calculates x coordinate. So this is going to be E8, but E7 is getting somewhere here with a minor error. And folks, that's basically question 2. All right, next up we've got question 3. We've got a product rule. I think there's a lot of product rule in this particular paper. So we've got y is equal to x to the power of half multiplied by sec 6x. So I'm going to put this as f and g. So I've got f is equal to x to the power of half, f dash is equal to half x to the power of negative half. G is equal to sec 6x. So g dash is going to be sec 6x tan 6x multiplied by the differentiation of whatever the bracket is. In this case, is going to be 6. And we're good. So we're going to get y dash is equal to f dash g plus f g dash. So f dash is equal to a half x to the power of negative half sec 6x plus f, which is x to the power of half. G dash is equal to 6 sec 6x tan 6x. And pretty much that's enough for an achieved there. No need to simplify anything. They do say that. Let me go to question B. Okay, so with this question, what are we looking at? For the function above, find the values of x where f of x is continuous but not differentiable. And I think the only part I could look at is this one here because it's continuous, but it's a sharp point, so you can't differentiate it. So for this, x is equal to 5. Second one, for the function above, find the values where the gradient is equal to 0. So we're looking for where the gradient is equal to 0. So the gradient is 0 here, and also from here to this point here. So the way we're going to write it is x is equal to 1, and also between 3 to 5. Continuous but not differentiable. And then finally, what is the value of x tends to negative 1 for f of x? So we're like looking at it, what's happening as it comes towards there. And it's both sides, from both sides, it's heading towards positive 1. So we can just say that and we're good to go. Now this one, you need 2 out of 3 correct. 2 of 3 for an achieved grade. Okay, moving on to question C. Question C, what we got is find values of stationary points. Okay, seriously, this is like x squared plus 5x plus 4. See, I would actually be a bit cheeky about this, and I'm going to try it slightly different and just to see if it works or not. So f of x is, I can factorize this as x minus 4 and x minus, no, it's not going to work actually. No, it's not going to work. That's fine, I just differentiate it as normal as it is. Okay, so I'm going to put this as u and v. So u is equal to x squared minus 5x plus 4. U dash is equal to 2x minus 5. V is x squared plus 5x plus 4. V dash is equal to 2x plus 5. So here, f dash of x is equal to u dash v plus uv dash. And I realized that this is actually quotient rule, so I got to divide by v squared. Okay, so with that in mind, now u dash is going to be 2x minus 5 multiplied by v, which is x squared plus 5x plus 4, minus, I've got u, which happens to be x squared minus 5x plus 4. V dash is 2x plus 5. Trying to see if there's a quicker way of doing this. And all of that is divided by v squared, which is x squared plus 5x plus 4 squared. Now the thing is, I'm trying to be super lazy and I'm not wanting to expand that numerator and put it all together. That's just painful. All I do know is that f dash, for stationary points, f dash of x is equal to 0. So what I can then say is the numerator should equal to 0. So if I do that, I'm going to get 2x minus 5 over x squared plus 5x plus 4. I don't think I can get away from this. I've got to expand this. Minus 2x plus 5 times x squared minus 5x plus 4 is equal to 0. Is there any way to not do this? Yeah, I had to think about this, and to be honest, the only part that I came up to, I got up to here because I did this. 2x minus 5 x squared plus 5x plus 4 is equal to 2x plus 5 x squared minus 5x plus 4. Now, I thought I could get rid of it by dividing it, but that's not going to work. So guess what? Oh, I hate doing this, but I have to expand the brackets by the looks of it. So I've got 2x squared, no, 2x cubed. Let's make sure we get this right. Plus 10x squared plus 8x minus 5x squared minus 25x minus 20. And on this side, 2x cubed minus 10x plus 10x squared plus 8x plus 5x squared minus 25x plus 20. Okay, so let's start canceling things out. 2x cubed disappears. 8x and 8x disappears. Negative 25x disappears. And I've got negative 5x squared minus 20 equals, hang on, let's just do this. That's going to be positive 5x squared minus 20. And then on this side, I'm going to have negative 5x squared plus 20. And if I bring all of that to one side, I'm going to get 10x squared minus 40 equals to 0. And I can take 10 out as a common factor. I'm going to get x squared minus 4 is equal to 0. So x squared minus 4 equals to 0. X is equal to plus or minus 2. So find the x values of any stationary points and the graph. I've actually figured that out, which is plus or minus 2. Grades wise, f dash of x is achieved. And then the plus or minus 2 is worth merit. Okay, question D, the classic rate of change question. So what we've been given here is we've got dv dt, which is equal to 3. We have been told that the height is the same as the diameter, so height is the same as 2 times the radius. And we've been asked to figure out what dH dt is when the pile is 4 centimeters in height. That means when the radius is equal to 2, at radius equals to 2. That's what it's asking. So to figure this out, what have I got? I've got volume of a cone, which is 1/3 pi squared h. And then I'm going to go 1/3 pi squared. Now h is equal to 2r. So then volume is equal to 2/3 pi r cubed. So dv dr is equal to 2 pi squared. Just check that. Yep, that's all good. And then dh dr is equal to 2. So if I look at dh dt, I should now be able to compile it, because I've got dh dr multiplied by, I want to have dr, I want to get rid of dr, so dr dv multiplied by dv dt. Yeah, that looks good there, because that's going to get rid of the drs. The dv is going to disappear, because basically what I've got is dh there. That's fine. And then the dt is here. The dr and the dr will kind of disappear, and the dv and dv is going to disappear. So dh dr is 2 multiplied by 1/2 pi squared multiplied by dv dt, which was 3. And when radius is equal to 2, I'm going to get 3/2 pi times r squared, 2 squared. So I should get 3/8 pi. Let me just double check that, folks. Yep, I knew something was not right with that. That's because I should have cancelled that 2. Because basically these 2's cancel out, and I'm going to get 3/pi r squared, which then is equal to 3/4 pi. H is in centimeters, time is in seconds, so centimeter per second. Okay, so grades wise, a correct expression for dH dt. That's correct expression for dH dt. I guess this, really? It's going to be an achieved. Wow. Correct value for dH dt with evidence of calculus method is a merit. Awesome. We'll move to the next question. All right, folks. So for this question here, what we're going to do is we've got to try and prove the largest possible area is this. Now, I'm going to go along here and I'm going to put this as x. So if we look at the area of this triangle here, all right, I'm just looking at this triangle. The green triangle is going to be half multiplied by base multiplied by height. Now, base is from here to here, which is going to be x, and then the height is going to be e to the power of negative x squared, whatever that is. So that's what the formula for the green triangle is going to be. All right, so this is, I'm just working at half this triangle. So if I do that, I'm going to get a half times base, which is x, and then times the height, which is going to be e to the power of negative x squared. Now, the largest possible area of this triangle is actually for the pink triangle. So that means we need to double this area here. So this is area for single triangle. So that's that. So area for large triangle is going to be 2 times a half times x times e to the power of negative x squared. So basically, area for that big triangle is going to be x e to the power of negative x squared. Now we're going to differentiate it. So area dash is going to be, well, we need to differentiate this, but looks like we've got yet another product rule. Someone's obsessed with product rule in this particular paper. So I'm going to put that as u and v. U is equal to x, u dash is equal to 1, v is equal to e to the power of negative x squared, v dash is equal to e to the power of negative x squared, multiplied by the differentiation of the power, which happens to be negative 2x. So we are going to get the area differentiated is going to be u dash v plus uv dash. So u dash is 1, v is e to the power of negative x squared, plus u, which happens to be x, multiplied by v dash, which is negative 2x, e to the power of negative x squared. So now e to the power of negative x squared can be taken out as a common factor. So we're going to get 1 plus x times negative 2x. So ultimately, we're going to have e to the power of negative x squared. And here we're going to have 1 minus 2x squared. So remember that area dash is equal to 0 to find is equal to 0 for max. And so we're going to say 0 is equal to e to the power of negative x squared multiplied by 1 minus 2x squared. So e to the power of negative x squared is equal to 0, or 1 minus 2x squared is equal to 0. Now this case, we don't have to worry about it because it's going to be invalid, no solutions. And then on this side, we're going to have negative 2x squared is equal to negative 1. X squared is equal to negative 1 over negative 2. So x squared is equal to 1 over 2. X is equal to plus or minus square root of 1 over 2. Now, in this particular question, we can actually ignore when x equals negative, I'm just going to put that as negative square root of 1 over 2. Ignore as x is greater than 0. Therefore, x is equal to square root of 1 over 2. So we need to figure out what the area is. So we're going to go back to the original area function, which is x times e to the power of negative x squared. So we are going to get x, which is equal to square root of 1 over 2. Now, there's one little thing that I just want to quickly, actually, no, maybe not. Now, let's forget it. Let's just do it all in one shot. So we're going to get 1 over 2 multiplied by e to the power of negative and square root of 1 over 2 squared. So we're going to get square root of 1 over 2 times e to the power of negative. That's going to be 1 over 2. But the thing is, we want to try and get to that final answer. The final answer is 1 over square root of 2e. So I'm going to write this as, I'm going to separate the square root of 1 and square root of 2 like this. Square root of 1 over square root of 2 multiplied by 1 over e to the power of positive half. Now square root of 1 is just 1 over square root of 2 times 1 over e to the power of half is just square root of e. Now I can combine the denominators and I'm going to get square root of 2e. And basically, folks, I've actually proved that the area is equal to 1 over square root of 2e. Now, grades-wise, correct expression for dA dx is going to get you an achieved. So we're looking at somewhere here for achieved. For merit, finding x equals to 1 over square root of 2 with the evidence of ignoring 1 over negative half. So you do need to do that to get a merit. E8 is getting the final answer. E7 is minor mistakes as you do this particular question. And folks, that's basically question 3 here. Just having a very quick look at cut scores. And again, it seems like getting very generous last year with the exam papers because the excellence was actually a 19. Usually I see 20 and 21, but 19 is very kind. And even a merit at 13 is actually pretty kind, I would say. But I guess that's because they've got so many product rules this time that, yeah. Anyway, that's your marking schedule there. All right, folks, so that's pretty much it for this particular paper. If you have any questions and comments and have shortcuts of doing certain questions, feel free to drop it in the comment section below. For this paper, I just wanted to wish you guys all the best for your exams. Don't leave anything empty. And yeah, there should be some things popping up soon. But yeah, good luck for your exams.
Hey guys, that is basically it for this video. As always, don't forget to like this video, share this video, and of course subscribe to keep up with the latest content. There should be some playlists popping up. Check them out. Great revision material. And as always, thank you for watching.